Okay, this is AP Calculus Practice Exam 2. This video we're going to cover numbers 21 through 30. Okay, so number 21, we have a graph. All right, and it looks something like that. Okay, and this is A, and this is B, and that is a graph of f. So it's not a graph of f prime, it's a graph of the function. So it says, which of the following is true for that graph? The function is differentiable from A to B. Okay, that's true. There's no breaks in the function. There's no sharp turns. So definitely number 1 is true. Number 2, there exists a number k on the interval a to b such that f prime of k is 0. Well, that's true because that just means the slope of the tangent line at some point k is 0. So we've got that situation in this graph. So part 2 is true. And then part 3 says the second derivative is greater than 0. Well, this entire graph is concave down. So the second derivative is going to be negative. All right, so it's concave down, so false. So 1 and 2 are true, and that is, the answer is C. Okay, so I don't think that was a really hard one, and I think that was one you could get pretty quick in maybe even like a 30-second type of problem. All right, I'll give you a second to pause the video if you need to. Okay, 22 says the velocity function of a moving particle on the x-axis is given by v of t is equal to t squared minus 3t minus 10. For what positive values of t is the particle speed increasing? Okay, whether a particle speed is increasing depends on the acceleration. So we're going to need to get the acceleration, but increasing occurs, or increasing speed occurs. You got to remember back to your physics. When velocity and acceleration have the same sign. Okay, so we are going to have to put together a sign line for both velocity and acceleration and see where they are the same. Their sign is the same. Okay, so if we set this equal to 0, I'm going to factor. You've got a t, and then we would have minus 5 plus 2. So if we were to do a sign line, our critical points occur at negative 2 and 5. So less than negative 2, let's say negative 3, that's going to be negative times negative, so that's positive. We'll pick 0 between negative 2 and 5, so that'd be negative times positive, so that is negative. And then greater than 5 is going to be positive. All right, let's look at A of t. So A of t is going to be the derivative of V of t. That's 2t minus 3, set that equal to 0, and our critical point is going to be at t is 3/2. So we'll do a sign line for acceleration. Got 3/2 to the left of 3/2, so I would pick 1 or 0, that's fine. But if it's 1, it's going to be negative. Greater than 3/2 would be positive. Okay, so it's the same sign between -2 and 3/2. Okay, and then greater than 5, they have the same sign. So let's look at our answers. And the one that'll work is answer D. Okay, so they don't go all the way back to -2. They start at 0, but for D, between 0 and 3/2, let's say this is 0, velocity and acceleration are both negative. And then for greater than 5, velocity and acceleration are both negative. So all of the other answers are incorrect. So that one is D. All right, number 23. Give you just a second on that one. Number 23, we've got another graph to take a look at. So it says the graph of F consists of 2 line segments and a semicircle. And all of this is occurring below the x-axis. Okay, so we've got 1, 2, -1, -2, and -1 there. So it said, what is the value from -2 to 2 of f of x dx? Well, this is just the area under that curve. So we need to figure out the area. Now it's going to be a negative value because it's below the x-axis. So you might be able to just look at that and see which ones are going to be negative, and the only one really looking at that's eliminated is D. Okay, so the rest of them could be the answer. All right, so the area of this triangle is going to be 1/2 times the base, which is 2, times the height, which is -1. So that's -2 times 1/2, so -1. And then for the semicircle, okay, the area of a circle is pi r squared. So it would be pi times the radius squared. Okay, and the radius is 1, so pi times 1 squared over 2, but it's also going to be negative because it's below the x-axis. So that's going to be -pi over 2. So it's going to be, the total area will be -1 plus -pi over 2, or 1 minus pi over 2. And looking at our options, that is C. So as long as you recognize that it's not D, and D they give you the positive, that if it's below the x-axis, then it's going to give you a negative value. As long as you recognize that, this is a pretty easy problem that you can work pretty fast. Okay, 24. What is the average value of the function y equals 3 cosine 2x on the interval -pi over 2 to pi over 2? Okay, the average value, we've done that formula a lot. So we know it's 1 over b minus a. Well, that's going to be 1 over pi over 2 minus -pi over 2. So that's 1 over pi over 2 plus pi over 2, which would be 1 over pi. From -pi over 2 to pi over 2 of 3 cosine 2x. Okay, so this is kind of a simple u substitution. So let's let u be 2x, du is 2 dx, so half a du is dx. Okay, so I've got 1 over pi out front. Okay, 1 over pi when you put that all together. I'm going to go ahead and bring the 3 out front. So times 3 out front, and then you've got a half, so times 3 halves. And then we're going from negative pi over 2 to pi over 2 of cosine u du. So that's going to be 3 over 2 pi, and then the antiderivative of cosine is sine, so sine u sine 2x, evaluated from negative pi over 2 to pi over 2. Okay, that's 3 over 2 pi times the sine of pi over 2 times 2. It's going to be pi, sine of pi, minus 3 over 2 pi times the sine of negative pi. Oh, well, the sine of pi is 0. The sine of negative pi is 0. Just be 0 minus 0 is 0. So I sure hope 0 is an option on number 24. It is. It is C. Okay, so a lot of work to get a 0, but you had to go through it. So that's one that's probably going to take you a little more than 2 minutes, but fortunately the last one was less than that. Okay, so that is 24. Like my marker's starting to get a little weak, so I think I'll try another one here. 25. We have f of x is the absolute value of x cubed. And we want to know the limit as x approaches negative 1 of f prime of x. So I've got to take the derivative of the absolute value of x cubed, and then we'll take the limit as x approaches negative 1. So here's the thing, when x is greater than 0, f of x, this is how absolute value works, is just equal to x cubed. When x is less than 0, f of x is equal to negative x cubed. So we have to look at it that way, and we then we're approaching negative 1, so it's going to be this second one. So f of x is equal to negative x cubed, so f prime of x is equal to negative 3x squared. So we're going to take the limit as x approaches negative 1 of negative 3x squared. So let's just plug that in. Plug in negative 1 squared. It's 1 times negative 3. You're going to get negative 3. All right, and 25, that is A. Okay, so that is, we have not taken the derivatives in class of absolute value functions, but it's really not hard. So this is one you might want to go back and study since we didn't cover that one in class, and maybe that'll bear fruit on the AP test. Okay, 26, a spherical balloon is being inflated. At the instant when the rate of increase of the volume of the sphere is 4 times the rate of increase of the radius of the sphere is. Okay, so you do have to remember that the volume of the sphere is 4/3 pi r cubed. I do not know on the actual AP test if they will expect you to know that or not, but this particular practice test does expect you to know it. And we have used that formula quite a few times. Now another thing, it says the rate of increase of the volume of the sphere is 4 times the rate of increase of the radius. So what that's saying is dv dt is equal to 4 dr dt. So I'm going to probably have to make a substitution in order to solve for the radius. Okay, so, but that's what the problem is telling you. So let's take the derivative here. We're going to d dt this thing. So I've got dv dt is equal to 4 pi r squared dr dt. All right, we know that dv dt is just 4 dr dt. All right, so I've got 4 dr dt is equal to 4 pi r squared dr dt. All right, well, the dr dt's are just going to cancel out. And I've got 4 is equal to 4 pi r squared. So 1 is equal to pi r squared. 1 over pi is equal to r squared. So 1 over the square root of pi is equal to r. All right, let's hope that's one of the answers. And it is B. Sorry if I was in the way for that one quite a bit, so I'll step out of the way for a second. Okay, so again, you had to make a substitution there from the very beginning information, and then after that, after you took the derivatives, a lot of stuff canceled out. Okay, 27. 27 is a classic differential equation problem. Okay, we have dy dx is equal to x squared over y. And our initial condition, when x is 0, y is 4. So we'll have to plug those numbers in to get our constant. All right, it just wants to know the differential, what's the differential equation. So we'll separate the variables by cross multiplying. Y dy is equal to x squared dx. Do that. 1/2 y squared is equal to 1/3 x cubed plus c. It's not so bad. Now let's put in the initial condition. 1/2 times 4 squared is equal to, well, we'll put a 0 in here. Right? That just goes to 0. So we have c. So 8 is equal to c. So we could finish this thing out. It would be 1/2 y squared is equal to 1/3 x cubed plus 8. And that is D. Okay, I think you probably could have gotten that one. You guys have worked those so many times. You probably could have gotten that one in under 2 minutes. You know, maybe that's one you could do in a minute even. So you're definitely going to get some of these on the AP test. Okay, 28, we're moving along pretty good. The area of the region enclosed by the graph of x is equal to y squared minus 1. Okay, you have to remember, okay, y squared minus 1. That is a sideways parabola. And its vertex is at -1. All right, so since it's positive y squared, it's going that direction, okay? And it wants to know this area between the x-axis and this is y squared minus 1. Okay, so the x-axis at x equals 0. Now we're going to need to know, where does it cross the x-axis? Well, when x is 0, you'd have y squared is equal to 1, right? 0 is equal to y squared minus 1, so y squared is equal to 1, y is equal to plus or minus 1. So you don't have your calculator on this part, so we've got a -1 to 1, and that's what we're going to be integrating from -1 to 1, right minus left. Right is 0, Left is y squared minus 1. So that's going to be negative 1 to 1 of negative y squared plus 1 dy. That's going to be negative 1/3 y cubed plus y from negative 1 to 1. All right, let's plug that in. Negative 1/3 times 1 cubed plus 1 minus negative 1/3 times negative 1 cubed plus negative 1. Negative 1/3 plus 1, then that's going to be minus 1/3 plus negative 1. 1/3 plus negative 1 minus negative 2/3. All right, so that's going to be 2/3 plus 2/3, which is 4/3. All right, a lot of fraction work there. So that is D. All right, you can do that. No question, that's one you can do. So a lot of these 30 that I've worked on this practice exam, pretty reasonable. A couple of toughies, but hey, you could nab more than half of these. I really think you could. All right, number 29. So we've got a graph. And that graph is f prime. So it's a graph of the derivative. And it says, at which value does the graph of f, the original equation, so that's f prime, have a horizontal tangent? Well, a horizontal tangent line has a slope of 0. So where does f prime equal to 0? That's where f is going to have a slope of 0, and it's at this point right here, which on the graph is x cubed. Okay, so you're not worried about the slope of the derivative. That tells you f double prime. You're looking at where is the original equation, f, have a horizontal tangent. That's where f prime is equal to 0. All right, and that is D. Hey, if you know what you're doing, if you've memorized those lists that we've made, you are going to be able to get that one just almost immediately. All right, and number 30. Says f of x is equal to negative absolute value of x minus 3. Which of the following are true? Well, what you're going to need to do is plot this. Absolute value is a graph that has a sharp turn. It's straight lines with a sharp turn. The negative means it's below the x-axis. And when x is 3, y is 0. So this graph looks like that. And they just expect you to kind of know that. All right, so what can we learn from that graph? Okay, so number 1, f, which of the following is true? F is differentiable at x equals 3. Well, at x equals 3, we've got a sharp turn. You can't differentiate that. So that is false. Sharp turn. So any of those answers that have Roman numeral 1 in it are toast, and none of them have it, okay? So how about 2? All right, f has an absolute minimum at x equals 3. Well, you just graph this. At 3, it's a max. Well, that's false. And a point of inflection. Okay, well these are straight lines. There's no curve. So there's no point of inflection. So that's false. So absolutely none of those are true, and that's going to be D. Okay, so that concludes practice exam 2, 21 through 30. That concludes the multiple choice part where you don't get to use your calculator. The next video, probably the next 2 videos, will concentrate on the next section, the multiple choice part where you do get your calculator. All right, thanks for watching.